Hey, good evening, one and all. Welcome to AWS Networking Deep Dive. It's so good to have you here. First of all, I would like to thank our community partners, that is Cloud Tech Online Meetup Group. We have partnered up with them so that their members could join this session and benefit from it. Second of all, I would like to thank all of you who have joined today. And without wasting much of your time, I would add the speaker. Hey, Suman.
Sure. Thanks, Karthik. Thanks for having me. Yeah.
So, Suman, could you please tell us about yourself and this topic that you're going to present today?
Yeah, sure. So what we are going to do today is we are going to talk about AWS networking. So networking is a a huge area in itself, and what we are going to do is we are going to talk about a few of the basic constructs, what you would encounter in your day-to-day work, and few of the advanced topics. And I would encourage everyone to dive deep into the certain topics of their interest. But this is one of the core services that we have. And we will discuss a few of those in next 30-40 minutes.
Okay, that's amazing, Suman. Could you please share your screen? Okay.
Yeah,
All right.
sure.
Thanks, on Suman. I'll go backstage.
Sure. Thank you so much, Karthik. I think your voice was breaking a little bit, so that's why I was not able to hear
Okay.
properly. So, thank you everyone once again for joining in, and I really appreciate all of your time you are spending in the evening. And what we are going to do today is we are going to talk about AWS networking, right? So before we get started, feel free to ask questions if you have any, and if you are watching this in a recorded version in the YouTube, feel free to ping me over LinkedIn or Twitter, wherever you feel like, or even in this recording in the comment section, so that I can reach out to you. My name is Suman. I am based out of Bangalore, and I work with the developer relations team here at AWS. And I predominantly focus on storage, machine learning, and serverless. So today we are going to talk about one of the core service called VPC and things around VPC. And I just thought that this may not be a very fancy topic with respect to other managed services that we have within AWS, but this is one of the important things that we all should learn. Right? So I'm also not a networking expert, but I just thought to share a few of the basic constructs and my learning on networking. So when we think about networking, the first thing that comes to our mind is the internet, right? So let's consider that this is our internet, and this is the AWS account that you have created, right? So let's say you have created a brand new account. So this is where you are in, and now you can create different resources within your AWS account, like let's say an EC2 instance, or an RDS instance, or an EMR cluster for data analysis, and all of that, or even any other resource, right? So what happens is these resources doesn't get created on air, right? It doesn't get created in the vacuum. So this all of these resources which you create, everything gets created within a default VPC, or a virtual private cloud, as we say it, right? So when you create an AWS account, you get a default VPC in all the regions. And what this default VPC gives you is an boundary, virtual boundary within your AWS account from the outside world, right? So whatever you do, it's only within your VPC. Now, when we talk about the default VPC, this is the address that it comes with. This is the CIDR range 172.31.0.0/16. We will go deep into this address in a moment, but this is the IP range that you get, and all the resources that you create within your VPC get some IP from this range, right? So if you see here, it is 31.0.0. This is the range, right? the CIDR range. And if you see, the IP of this instance is 0.128, 1.24, 1.27, and so on and so forth, right? So all these IPs are belongs to this CIDR range, right? Or rather CIDR block. So what else do you get from the default VPC? You get different subnets. Now, what is a subnet? Subnet is basically a grouping of your whole IP range, right? So if you look here, we have two AZs, let's say in this region, wherever you have created this VPC. This is the default VPC, but the concepts are exactly same if you create your own custom VPC, right? So whichever region that you create this VPC, you will have a different availability zone, and in each availability zone you can have one or more subnets, right? So in this case we have AZ1 and AZ2, and each of them will have a different subnet, right? So if you see here, the subnet range is like the from the IP address itself, you can say there is 31.1, 31.1, but here it's 31.0 and 31.0, right? So there is a different smaller set of address spaces from your actual VPC CIDR block or the VPC IP range that you get within your availability zone in the form of two different subnets. Apart from that, you need to connect to the internet, so you also get an internet gateway, and we are going to talk about internet gateway in a moment. So this is also something that comes with your default VPC. And obviously you will have security group and NACL, and these are the things that we are going to discuss next. So I'm not stretching on these 3 points, okay, and because these three we will discuss in a moment from now. But all of these comes with your default VPC. When you create an account, this is what you get in all the regions where we operate in. Okay, so now let's talk about few of the VPC concepts and fundamentals. So to start off with, we will discuss about the different IP addressing. That is, how the addressing looks like. We have seen a little bit about that a while back, but we will just go a little deep into this. We will also see how you can create a subnet, and how the traffic routes through the VPC, right? Not only within the VPC but also outside VPC. And finally, we will look into security, and this is where that security group or NACL comes into picture. Okay, so these are the four things that we will discuss. So let's start with the IP range. Right? So when you create a VPC, it is very important that you select your IP range properly, because that only defines how many resources that you can have within your VPC. Right. So let's go back to this IP 172.31.0.16, and this is not a random IP. This is a private range IP which is mentioned in this RFC 1918. If you want to deep dive into this, you can refer to this RFC, and in that you will see that this is one of the IP range out of many other IP range which is mentioned in this literature, which says that this IP range is private. So you will not find any internet resource or anything which has this IP. So you are always sure that within your VPC, this IP will not conflict with anyone outside your VPC, right? So this is a private IP range which is not available in the internet. And if you look at this /16, this says the subnet basically. This is the host address space, and this is the actual, the network address space, and this is the actual address of the host or instance, whatever we call it, right? So if you have /16, you will get 65,000 addresses, right? It's just basically the mask. So just to avoid conflict, because when you create a different VPCs, lots of VPCs, you may not want to communicate within VPC on day one, but it might so happen that in future, as you continue to develop and work and build mature softwares, it might happen that you want to have one instance from one VPC talking to another instance in another VPC, right? So in that case, we need to make sure that there is no IP conflict. So always have this in the design I would say, guidelines that you should avoid any IP overlapping, right? So because if you have duplicate IPs across VPCs or across network, right, you will not be able to communicate, right? So basically, it's a fundamental of networking. Now, how you create these subnets? As we have discussed, every availability zone will have a different subnet. So let's say you have three different AZs here: EU West 1A, 1B, 1C, and you will get three different. You create three different subnets, and all these three different subnets will have a three different slice of address from this VPC address cider range, right? So it is 0.0, and if you see here, this is 0.0 slash 24. This is 1.0 slash 24. This is 2.0 slash 24. So this is how you slice and dice your VPC address space into different subnets or different availability zone. And as I mentioned before, you can have multiple subnets within an availability zone, and you can pick the address range accordingly, right? So all the address range should come from your VPC CIDR range, right? So that's why when you pick up this address, you need to make sure that how many resources or address you might need, considering your future growth and all of that, or your business growth. All right, so now we have talked about IP v4 so far, and as we all know, I guess almost a decade back, people started to work on IPv6 support as well, and we are also no different. So on AWS also we support IPv6, and there are subtle difference between IPv6 and IPv4. One of the important differentiation is that you cannot change these address spaces. So you can have /56 for VPC address or CIDR, and you will have when you create subnets, you will get /64 address space. So you cannot change that. And the other thing is, all the addresses all the addresses that you get from IPv6, all are publicly routable. So basically those addresses are not private, so they are routable outside. So it's basically a unique address on this planet, right? So it's you need to think that way. It's not a private IP, because we have millions and billions of IPs, so we can afford to have a uniqueness there. So always remember, IPv6 in your VPC are publicly routable, okay, unlike IPv4, where you can have public IP as well as a private IP. So now the way that it works within your VPC, if you go back to the same slide, it works in a dual stack. So when you enable or when you need an IPv6 support, you can enable that at the time of creation, and it will get an IPv6 address for all your subnet. Okay, just like how you get for IPv4. Okay, it's just that you cannot define this; you will get automatically from AWS. All right. So the last thing, after we create a VPC and subnet, is the routing, right? So how packet flows within VPC, and not only within VPC but also outside VPC. So the way that we define the routes is using a route table or route table, and it contains a certain rules. Okay, so that means in the route table, you define that if the packet is coming for a particular destination, what to do, right? So this is where you put your routing table, right? And the default VPC and the subnets, it will have a default route table, but you can always create and assign that route table to any of the other subnets. So you can define your own route table. So how it looks like? It looks like something like this. If you go to any of the subnet, and we can see that in the console as well, but this is the route that you would see. So this is, let's say, this is the VPC address range, the whole CIDR range, and it says active. And this is for the IPv6, and it is also saying it's active. So that means here all traffic which are designed within the VPC always stays within your VPC, right? So it doesn't say, at least at this stage, what you see on your screen. any instance that you create will not have any internet access, right? Because for internet it will be a some public address, right? So let's say 8.8.8.8, whatever it is, right? So it will not find any routing information from this table, so it will not be able to process that. Okay, and we are going to see that how we can connect to internet next. But this is how a route table looks like. Okay, so it has a destination and it has a target, like if any traffic comes for this range of IPs, where to go. So here local means stays within your VPC. Now, talking about internet, how it gets connected to the internet. So let's look visually. Okay, so so far you have seen this, right? So we have the VPC, we have two availability zone, and we have four subnets. So we have not talked about private subnet or public subnet. As you can see here, there is a private public subnet and there is a private subnet. Similarly, we have another public and private subnet here, but I'll come back to this private and public thing in a moment. But for now, as the name defines, or you might have got an idea. Private subnet is a subnet from where internet access is not possible, and a public subnet is a subnet from where you can access the internet. Right. So just hold on to this thought, and we will see how it can access the internet. But before we jump into how an instance from any of the subnet access internet, I want to talk about these services which are highlighted in in colorful icons here. So within AWS, we have a lot of services that you create which stays within your VPC, and there are a lot of services which are part of AWS, but they are not part of your VPC. So basically, these services like S3, DynamoDB, and so on and so forth, they all have a public. They all have a public address space. So basically, they are not. Within your VPC, it's kind of an internet facing service, although it is within AWS, but they all have an public address space. Okay, so when we think about having any of your instance here talking to internet, okay, we need to consider not only this, but we have to consider how it will talk to other services which are within AWS but not within your VPC. Okay, so that's why we have shown all these public facing services as well as the generic internet. Okay, so let's see how it all works. So let's say you have four instances in all these four subnets. So the first thing that we do is, let's say if you want this instance A, which is in this public subnet, to have some connectivity, we will have some route table, right? And this route table will have some rules. As we have seen, it will be by default local. That means it can talk to any of the instance within this VPC. Similarly, another instance in a private subnet will also have a route table, and it will also have the same route entry, or the rule that it can talk to anyone within the VPC. Now, to have an internet access, what you need is you need to have an internet gateway, and this is at the VPC level, and that's why the icon is on top of uh, uh, all the subnets, right? And what happens is, once you have an internet gateway, you need to have an entry in your route table that for any of the address which are outside this normal VPC address range, which is 10.1.0.0, because 10.1.0.0 slash 16 is the VPC CIDR range, right? So if any traffic which is have the destination address outside this 10.1.0.0, go to internet gateway. Okay, that is what this entry means. So you cannot just create an internet gateway and assume that all your instances within your VPC will have internet access. Okay, so you need to update this route table. Now, the moment you do that, what happens is, your when you try to access, let's say when you try to access instance A tries to access internet, it need to have a public IP, right? And all this mapping between that temporary public IP and the private IP is maintained by this internet gateway. right? And that is what this elastic IP is. So this is the public IP, and this is the private IP, and this tuple is maintained by the internet gateway. And now this instance A can talk to all the services which are there within the AWS, which are public facing or has a public facing address. And not only that, it can also access internet, right? So this is how any instance which are part of public subnet access the internet. Okay, it's through an internet gateway. That is the first thing that you have to do. Second is you need to add an entry in the route table. That's all. Okay, now the second immediate question comes, what happens to private subnets, right? So the way that you can have any instance which are in private subnet to have internet connectivity is through NAT, okay, network address translator. And why we need that? Assume that these instances are, let's say, the database instance or any backend server instance, and they might need internet, not always, but at times, maybe for patching or something like that, right? So in that case, you need to have something called NAT. So and that NAT instance need to be in one of the public subnet. Okay, so you might be getting an idea what we are going to do now, right? So the moment you create a NAT instance, you have to have an entry in this route table and say that anything which is having any IP except this internal VPC IP range or CIDR range, go to instance B. Now I give all the, so instance C will give all the responsibility to instance B to take care of all the packets to go to the internet. Okay. So now what happens is, what NAT will do is it will talk to internet gateway, and it will have an IP, again the same IP tuple which contains the private IP and the public IP, and it will manage that, and it will allow an access to the internet. Okay, so that's how the NAT instance work, right? And this is how we have been telling our customers or developers to work with any instance which is in the private subnet, which needs to have internet access. But now we do not recommend that. We do not recommend NAT instance, and instead of that, we have come up with another product called NAT Gateway, which is much more scalable and an easy product. So you can just create a NAT gateway, and you can just use the internet. But since we have changed this NAT instance to NAT gateway, we have to remove this entry in the route table, and we have to give the new entry of NAT gateway. Okay, so that's the only difference. So if you want to learn more about NAT, you can read the documentation. It's basically a Linux system, all right, and it has some a separate set of packages and all of that. But now you don't have to manage all those EC2 instances which is running those special packages and all of that. You can just create a NAT gateway and you are done, right? So to summarize, whether it's public or private subnet, to have an internet access, you need to have an internet gateway and NAT gateway, depending on if you want any access from private subnet or public subnet. If from public subnet, you don't need any NAT gateway, you can go ahead with internet gateway and you're good. Okay, so that's about routing. And the last thing is the network security. Now, there are a lot of different topics around network security, and security is one of the major thing within AWS for any service for that matter. So what we are going to do today is we'll just touch base upon these three important constructs. Okay, security group, NACL, and flow logs. So let's start with security group. So let's say this is your VPC, and we have an internet gateway, as you can see in the top, and we have internet. Although these two doesn't matter, but just it's there. That's why I'm just saying. But let's say you have 7 instances, and you have 4 instances. Let's say web servers, and let's say you have 3 instances of, let's say, database or any of the backend server. And now what you want to do is you want to do a different grouping of these two set of servers. Okay, and this is what security groups are. So it's basically a virtual firewall where you can define rules for a different set of groups, and any instance within that group need to adhere to that, right? So in this case, we have two security groups, my web server and my backend server. And now in the my web server, I can say allow any web traffic on 0.0.0.0, and which makes sense, right? Because it's an internet facing application that you are going to develop, and these all are web servers, so you need to have this access. But your backend server only need to talk to the web server. So in this case, in this security group, that is my backend server, you will not have allow to all traffic on 0.0.0, right? So here you can give access to only allow traffic only from my web server security group. Okay, so this is one of the best feature in terms of security as far as the networking is concerned. And this is how the security group would look like. So let's say you create two security group, my web server and my backend server. And now we have selected this my web server, and if you see here, we have traffic on for all the HTTP requests from 0.0.0.0, right? So all traffic it will allow. Similarly, for IPv6, we have another entry, but if you're not using IPv6, then only first entry would be there, right? Now, let's select the backend server. Now, the moment you see the backend server, you will see that in the source, we don't have any IP, but we have another security group, which is nothing but the my web server security group, right? So this is very important that when you create a security group, you can either give a range of IPs, and not only that, but you can also give another security group. So that's how flexible it is, because as and when your infrastructure grows, your application grows, you might not want to define different rules for different IP ranges, but you can group them all together in a logical firewall like a security group, and you can use that security group to be part of another security group. Just in this case, as you can see, the backend security group allows traffic only from the front end or the web server security group. Now, this is good. So this is a virtual firewall, and there is another security construct that we have called NACL. We are not going to go deep into NACL, but the idea about NACL and security group, if you look at the difference, is this. First is security group operates at an instance level, but NACL operates at a subnet level. So you have to define a NACL for a particular subnet, whereas security group, you can create different security group, and you can put different instances on that security group, just like we have seen, right? Web servers and the backend server security group. And but what is the most important thing is in security group and NACL is security group uh, allows only it only allows allow rules, okay, whereas network ACL or NACL, you can define allow as well as deny rules, okay. And a security group are stateful. That means if you allow traffic from A to B, it automatically from B to A also it comes under a allow rule. But that may not be true for all the cases, right? So if you want to have a different set of rules for inbound and outbound, you can use NACL. Okay, so that's what NACL and security groups are. One thing that you need to remember is one is stateful and another is stateless. So like NACL, and one operates at an instance level and another one operates at a subnet level. So these are the two most important thing which we need to remember, right? So that's about network security. And the last thing is the flow log. So far, we have talked about how you can harden the security within your VPC, right? But we have not talked about, how you can actually monitor this, right? What traffic is coming and going and all of that. This is where a VPC flow log comes into picture. So you have your VPC, And what you can do is you can enable or create flow logs. Now flow log you can enable or create at different level. You can create it at a VPC level, or at an AZ or subnet level, or at an instance level, right? All these three different levels you can have this VPC flow log. And what it would do is it will monitor all the traffic, and it doesn't read the payload, but it just reads the description. So it's not like it is reading your data, but it will just have the information, like from which source to which destination address, which port to which port, and so on and so forth, right? And it will tell you accept or reject. So if you have ever played around Wireshark or any of the network traffic analyzer, it is similar to that. And once it analyzes, it need to save that data. So it allows you to save the data either in S3 or CloudWatch, right? So these are the few things that you can do. You can get a good visibility about your traffic within your network. It is good for troubleshooting, and obviously it is useful for analyzing traffic. And this is how it looks like, and what you can do to create one. So you go to your VPC, select your VPC, whichever you have, maybe default or your custom VPC, and then go to flow log and click on this create flow log. It's as simple as that. Okay, and since we have seen that it has two destinations, either it can be saved in S3 or it could be saved in CloudWatch, right? It's up to you. Now, the last thing before we wrap up on this section is how this flow log looks like. There are a lot of distractions here, but just try to focus on line number 1, and you will see that it has a source IP address, right? It has the destination IP address. So source at IP address is this, destination IP address is this, and this is the source port, and this is the target port. And then we have a few other information, like when it has come, how many bytes of information we have, and whether it's an accept or reject. And based on that, you can have some maybe you would read these logs, and you may take some do some analysis using Athena, maybe on S3, because all these data is dumped into your S3 bucket, right? So you can do a lot of analysis about your audit and traffic flow control in general. Okay, so that's about VPC flow log. So the last thing on this is, how about, or what about DNS? We have been talking about IP, but there should be some DNS service, and surely yes. So within your VPC, we have two options that you can go with. We have DNS resolution and DNS hostname. Both are enabled, as you can see here. And what this allows you to do is, whenever you create an instance, you don't have to remember the IP address of that. It will automatically assign a host name, and similarly, it will do the resolution of those addresses when needed, right? So we do have the VPC have this DNS options, right? So you can always make use of that. So it automatically assigns host names to these instances. Okay, so the last section, which is so far whatever we have discussed, these all are basic and core constructs of VPC. So these are the things that we all of us should know. To what details, it depends on what at what level you are working. So if you are a software developer, you may not need to know everything around how things work. But if you are from the infrastructure team, or if you are an architect, you may need to know a little bit more beyond what we have just talked about. Okay, so before we go to the last section, I just want to check if we got any questions. If not, I'll just continue. Okay, so it seems that we are good. So I don't see any questions. Let me see. Mm, how do you link security group to VPC? Okay, so I think Gautam has asked one question. So let's open the console. Okay, so this is my console. Okay, and this is my VPC. I've just clicked on VPC, and what we can do is we can come to security groups, right? Let's say security groups, and now we are going to create one security group. So let's click on security group, and we can give some name. Let's say my front end uh, SG. Okay, and we can have some inbound rules and outbound rules. So let's say inbound rules as HTTP. Yes. Okay, and let's say uh, we give to everyone. Okay, and if you see here, you can also define that. Let me just delete this. You can also define my address, so it will take your address automatically. Okay, so let's go to custom and say 0.0.0. Okay, and let's come down and click on create security group. Okay, we have to give some description. Let me copy paste here and create this. So now this security group got created, right? And now the next thing what we can do is, whenever we create an EC2 instance, we can attach this security group. So we can put that, or rather, let me rephrase it. We can have instance in this security group, right? So what I want to show you is, let me go and create another security group. Okay, so let me go to security group, uh, create a new security group, and here we will say my backend security group. Okay, and in this case, I'm going to have, let's say, TCP, only TCP traffic, uh, and here I want to have the security group, the front end security group, right? So this is my front end security. So you can search it here. It will automatically select the security group. So this is my front end security group which I have created, and I can always create this security group. So now when you create any resource like an EC2 instance, let's say any backend server, you have to give this security group, during the creation of EC2 instances. Okay, so you can always create security group standalone. Okay, so Ankit is having a question. Could you tell us how a NAT gateway work? Okay, so behind the scene, what happens is, basically, if you look at, let me go back to the slide. Where is this? Give me a moment. Okay, I'm just trying to fetch that. Yeah. Yeah, so what happens is, basically, if you look at this, is what we want is, just yeah. So basically, what happens is, when you create a NAT gateway, it's basically an instance only, right? At the end of the day, it's also a system, let's say a Linux system. And what it does is, it's kind of how you have seen any Bastion host work, right? So you don't allow any traffic from outside internet to this NAT gateway and then come to instance C. It just do not allow. So you can think of it as a kind of a security guard, right? So who has the visibility of outside world, and the way that it does that is, it takes all the packets from any of the instance within that VPC, and then it talks to the internet gateway. Okay, so it doesn't. So the idea of having a private subnet is not to give internet gateway in this route table, right? If that happens, then what that eventually would mean is, anyone, anything in this subnet can talk to internet, which we don't want, right? We don't want that. So we just want only outbound traffic from this instance to internet to flow, right? Not the other way around, right? So that's where the NAT gateway comes into picture. It just takes, you can think of it as a gatekeeper, and it will just translate the address from an private address to a public address without exposing the actual instance. So if you see here, when it is trying to send the traffic from instance C to the internet, it is not using that IP address. So its IP address is 2.11, but here it's 1.11. So it is completely masking whatever address it is getting, or it's only NAT gateway who has that idea or has that information from where it is coming. So it might happen that instance D also can ask for internet access, right? Maybe some patch download or upload, sorry, not upload, maybe, and patch upgrade or something like that, right? So that's how NAT gateway can help. Okay, so that's about this. So if you have any further questions, let me know. I'll just take that offline. Okay, so um is there any other? Yeah, I think Rahul has a question. Could you please tell AWS firewall service? I have not used other services, so I may not be the right person, Rahul. But I can share you few of the resources which you can go over, and you might get some insights. Because there are a lot of products in that space in the enterprise market which I'm not aware of, but I'll be happy to share that information. Okay, yeah. Uh, 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 there is a question. Once I have deleted, Amruta asking this. Once I have deleted one old NAT gateway, it is not deleted properly. Created a new one. Now I have multiple NAT gateway in the VPC. Now traffic backholding is happening. How to find the old one and delete it? Okay, that's that's an interesting question. I'm not very sure how, why you are not able to see. I think you should be able to see the NAT gateway, the old one as well. But if you want to but even if you have the old one, if you have created a new one, and if you see this, if you have created a new one, and if you have uh, if you have updated the route table with the new one, the traffic should use the new NAT gateway, not the old one. Okay, so this is a specific thing. If you have anything, you can send a screenshot or whatever, maybe the command output, I can try to see. Okay, all right. So what else? Uh, yeah, I think any private NAT, any reference document. Yeah, yeah. There are a lot of reference. I'll share it with you. If you don't mind, can you just ping? If you can ping me on LinkedIn, I'll share it with you. Okay. All right. So what else? Okay. So does it work like a router which has DNAT enabled? Ankit, and I did not get the question. Can you just repeat it once? Okay. So by that time, I'll just move on to the next, last part. Okay. Um, okay. So I think he uh, Tala has a question. Uh, how will an instance in a private subnet access other AWS service like S3 and DynamoDB? So as we can see here, it will access through. There are different ways that it can access, but if you consider this, it will access the same way as it access the internet. Okay, so the traffic will, let's say this instance C tries to access S3. Okay, so it will use this NAT gateway. It'll go to the internet gateway, and then from internet gateway, it'll go and get the S3 access. But there are different other ways that it can access, and which we are going to touch base next. Okay, but this is the basic one. Okay, so let me put this into the presentation mode. Okay, and then we'll just try to finish this off. Okay. Let me come to the slide. Okay. All right. So we talked about VPC and different components within the VPC, but how about different VPCs, right? So let's say you want to connect from one VPC to another VPC, or you want to connect to your on-premise data center, right? If you have an on-premise data center, how will you connect, right? We talked about VPC, but now we are thinking big, right? Outside your VPC. Now there are different services that we have. One is VPC peering, and another is transit gateway. So VPC peering came first, and we will discuss, how transit gateway, is helpful. And you may not use VPC peering always, right? If you're running it at that big scale, okay. And we are going to talk about that. But let's start with VPC peering. Okay, so how it works. So let's say you have a VPC A, we have another VPC B, and we have VPC C and VPC D. Okay. So now what VPC peering says that if you want two VPC to talk to each other, you just have to create two different peering. Okay. So there will be one peering between A and D and another peering between B and C. Okay. So similarly, as you might have guessed, if I want to, have some connectivity between A and B, I cannot just go through different path. Okay, so I have to have another path between A and B. Okay, so that's what VPC peering is about. It's between two VPC, and you need to create more and more peering as and when you need. So you can think about this that it is quite cumbersome if you have lots of VPCs and you want all different VPCs to talk to each other, right? So this may not be that scalable, right? And also this is the point which I was talking about initially, that your IP range should be unique, right? If you have two VPCs of same range, there will be an IP overlap, and it won't be able to communicate, right? And this is where the planning for IP range at the time of VPC creation comes into picture, right? So now how you create an VPC peering, it's pretty much like an TCP handshaking protocol, if you're aware of. So the first step is, let's say one of the VPC, like in this case the left hand side VPC, which is 31.0.0, it initiates a request, and it accepts the request. And then at the end, what happens is you need to just update the route table, right? So if you see the route table, now this route table is the route table for this VPC. Okay, so now don't look at this table, but in this route table we should have this IP address, right? And this is exactly what we have it here, right? And in this case, what we are saying is, as a target, we are giving this VPC peering construct. Okay, so that means that now any traffic can go from this VPC to this VPC. All right, so basically, you have made a route between any of the instance from this VPC to this VPC. So similarly, if you have multiple VPCs connecting across each other, you need to update all these route tables in all those VPCs. Okay, so it's little bit cumbersome, but this is what we have to do. Okay, now how about connecting to other VPCs? And not only that, how about connecting to on-premise systems, right, or data center? And this is where transit gateway comes into picture. So as we have seen, without a transit gateway, which we have not discussed yet, with VPC peering, if you have two VPC, you will have a VPC peer. You will have another two VPC, you will have another VPC peer, and so on and so forth, right? And this will clutter a lot, right, as and when you grow. And similarly, if you have your own data center, in that data center you have to first create a customer gateway, or rather you can think of this as a VPN, which you might have in your data center. And then you will have a VPN connection between a different VPCs. Like every VPC, you need to have a different VPN connection, right? There is one way. This is one of the way that how you connect your on-premise uh, infrastructure with AWS, and there is another way called AWS Direct Connect Gateway. And in this case also, if you want to have the connectivity within your VPC, you have to have connectivity between each and every VPC like this, right? So you can think of this as a very cluttered architecture as you grow, right? And this is where transit gateway comes into picture. So you have two VPCs, and what you do is you just create a transit gateway. That's all. And then you connect these two VPCs. Similarly, if you have two more, you don't have to create another VPC peering as we have seen before. Everyone can now talk to the transit gateway, right? So not only within AWS, but also from your on-premise data center using a customer gateway and VPN. So transit gateway is the single point of construct, virtual construct, which can talk to other VPCs, not only within your AWS account, but also outside within your data center. Okay, so this is how transit gateway works. So you might ask, if this is so good, why do we need VPC peering? So it's up to you which one to select, and we need to think about which one we should go with. If you have less number of VPCs, then you don't have to create transit gateway. You can go ahead with VPC peering itself. But if it's more, then you may like to think about transit gateway. Okay, so that's there are some limits, but these numbers keeps on changing. But really don't want to spend much of the time. Okay, so one last thing that I have is how you actually connect to your on-premise network from your VPC. So let's say you have the VPC here, and this is your office. This is your office data center, right? This is your office data center, and this is your VPC. So the way that you can connect, there are two different ways. One is using AWS VPN, which we just touched based upon, and the another one is direct connect. Okay, so let's talk about the AWS VPN first. So what you do is you create a customer a gateway first in your data center. This would be your networking device, so it could be a router or a firewall or whatever, right? And next, what you create is a virtual private gateway in your VPC. So this is all AWS here in this side, right? And the moment you create that, you can have a connectivity or VPN connectivity. And what it does internally is we create two IPsec tunnels. Okay, and the reason that we have two separate IPv6 tunnels is because we have two separate VPN termination endpoints in two different availability zones for high availability, right? So if you are not using any dynamic routing protocol like BGP, for example, you may have to update the route table within your VPC, as you can see it here, right? So that's how you create. So first you create a customer gateway, and then you create a virtual private gateway, and then you just have a VPN connectivity. But this may not be good always, because you may not want your data to flow from the internet, from your database, from your data center to AWS. You may not want always transfer to be through internet, although it's secure and all of that, but still you may not want that. So in that case, we have direct connect. So how it works, it's pretty simple. Just like before, you have a VPC, you have your AWS account, you have the virtual private gateway, and you have your data center, right? This is your customer environment or your office network. Now, what you do is you have to check in our AWS website where are the direct connect locations. So there are different direct connect locations. You have to pick the location which is nearest to your office or this customer network. And these direct connect locations are the places where we have lots of networking gear, routers and ports and all of that. So you can connect your data center with the direct connect, either yourself or through any of the partners that we have, right? And once you have that, you will get you will have your virtual private interface talking to your VPC. Not only that, if you want to, someone was asking, right, how to connect to AWS public facing services like S3 DynamoDB. So you can connect through the public virtual interface, all using the direct connect, so that you don't have to go to internet and all of that. So it's basically a direct tunnel to your AWS account. Okay, so that's about the how you can connect through your data center from your VPC. I know there are a lot of content that we have discussed today. I did have few more slides on few of the advanced topics like VPC sharing and all of that, but I think you can get those things of your own. It's pretty straightforward, but those are little advanced topic, and you may not need it unless and until you are from infrastructure background. So that's all from my side. I see there are a few more questions. Let me just check one or two questions. Uh, so there is a question from Ankit. We create roles. Okay, you are just responding. Okay. Um, yes, Ankit. Yeah, you are correct. Yes. So uh, through transit gateway can be accessed on-premise machine. Yeah. So that's correct. You can have access, but you need to have either a VPN or and a direct connect, right? So that you need to have. So if you see here, where is that? Yeah, when you have a transit gateway, still you need a direct connect or this VPN network to connect to your AWS account, right? So this all the middle part is your AWS, and this is your customer gateway or customer data center or your on-premise data center. So you can either use a direct connect or VPN connectivity, as we have just seen, right? So you can do that. Okay, so. Could you please tell about direct connect and that transit gateway? Okay, yeah, sure, Ankit. So basically, if you see here, transit gateway, the way that you can think of transit gateway is how you can create, remove this mess. So in VPC tiering, what happens is two VPC talk to each other, only two VPCs, right? And every time you need to have a connectivity, you need to have 1:1 ratio connectivity, right? So it's not that scalable, and that's where transit gateway comes into picture. So that's now it's a single construct. You connect all your VPC to this transit gateway, and now this transit gateway can talk to everyone outside AWS, right? So whether it's a AWS on-premise or whatever, all right? So now how to connect your on-premise to AWS network, that's a different thing altogether, right? So how you connect your on-premise to your AWS account or AWS network is through either AWS VPN or direct connect, right? So now whichever you choose, you feel free to choose, and then once you choose that, then you can use transit gateway to actually talk to your VPC. Okay. Okay, excellent. So, yeah, what is the best strategy to migrate? So migration is not only about the networking, right? So a lot of things in terms of application, and networking is one of the crucial thing to think about. But when you think about migration, it's more we need to think from the application standpoint how you do that. But if I assume that you have considered everything from the application standpoint, and you are just talking about the infrastructure, in that case, you may start with AWS VPN, because direct connect you may not. That is something you can do it later on. So you can just have a VPN connectivity, and you can test how things are working across two data centers, like not two data center, how it is working from your data center to AWS, right? So that should be the first thing that you can explore. And then if things goes fine and you have a very big business, you may like to go ahead with a direct connect, because it would be most it's everything is secure, but At times you may not need internet, you don't want your traffic to go through internet, so in that case you can use direct connect, and also it will be of less latency because you have a direct access to the AWS resources. Okay, so how different is the networking in AWS Outpost? JB, I have not worked on AWS Outpost. I'm not very sure, what is the exact difference. I do not work on that, but the basic concept should be same. The Outpost is when you think about Outpost, it's basically uh, the hardware that we ship to on premise, right? So you get all the features and flexibility that you could do on cloud. But now how you connect that to AWS, let's say you have an AWS resource on cloud on your account, and how you connect through Outpost, I'm not very sure because I've not worked on that, but yeah, I can find that answer for you. um, Talked about unicast traffic. What about yeah, so we don't have a broadcast and multi-class. That's a good question. We don't have anything like that. We do have some IP so when you that's a good question actually. So when you create a subnet, right, you have a subnet range, IP range. So within that IP range, I think there are 5 addresses which are reserved. And those let me just find out if I have that open, I guess. Mm, we don't have anything like that, which you are talking about. But I just want to show you. Yeah, these are the. Okay, I found that. Okay, so these are the 5 addresses which are reserved. So for any subnet that you create, right? If you see here, let me just zoom a bit. So this is also important from sizing standpoint. When you create a subnet, what address space that you use, always subtract 5 addresses, and those 5 addresses are used for specific reasons, and those are the first 4 address and the last address. So the last address is the network broadcast address, and we don't support broadcast in a VPC, and that's why it is reserved. So you cannot use this. And this is for future use, and this is for the network address, and this is for the VPC router, and another one is for DNS, and this is for that DNS host resolution and discovery, right? So that's about this. So we don't have anything like broadcast or multicast within that VPC, which you can change or tap around. Okay, cool. So I guess I'm already shooting up on the time, but feel free to ask questions maybe on LinkedIn. I'll take that forward. I can keep on talking, but since it's evening time, that's why you might have some other work. But if you have any other questions, I'm online. You can ask me. I'll be more than happy to answer. And thank you so much for all of your time. Really great questions. Feel free to ask more questions. And if you want, let me just show you quickly. I wanted to share a few other things, which are these. Okay. Which are these. Okay, VPC sharing and VPC endpoint, because endpoint is something important. I'm not going to share it today because we don't have much time, but I'm going to have same session with these details in Reskill platform. I think if Karthik can share that link, you can go over that maybe next month, and we'll have some quiz attached to this, and I'll take few of your questions as quiz. So there are a lot of good questions that you have asked, but feel free to hang around that next month if you want to know more. Otherwise, as always, feel free to ping me anytime, on any of the platform of your choice. Yeah. So back to you, Karthik. Thank you so much for your time.
Hey Suman, thank you so much. The session was really interesting. The audience really enjoyed it. And guys, please feel free to reach out to Suman on LinkedIn if you have any questions for him, as he said. And you will find all the links mentioned in the stream in chat. So thank you all for joining today.
Thanks everyone. Have a great evening. And yeah, bye. Bye. Take care.
Bye, everyone.